Today we're going to talk about using the laws of exponents. So when we're talking about exponents, we have an acronym called MATSPAM. In MATSPAM, it's broken up into three different sections. The first section is MA, and this is when you see multiplication, then you are going to add the exponents. The second one is DS. When you see division, you are going to subtract the exponents. And the third one is going to be PM, and that's when you see parentheses, you're going to multiply your exponent. Now, I want you to remember that mathematicians are lazy. So, in that, I mean, when you see this x over here by itself, you have to remember that there are invisible numbers involved. The first invisible number you're going to find is the 1 in front for the coefficient, the x, which is what you see, and the 1 that it is raised to, because all of the information we're talking about today have exponents or small numbers that are raised to a letter or a variable. So let's look at what happens when you have product of powers. It says a to the m times a to the n, which really means a to the m plus n. That is when you see multiplication, then you add. Now let me show you what I mean. What I'm going to do is I'm going to take the big numbers, which are the coefficients, and I'm going to treat them like regular numbers. Because I see parentheses here, I'm going to take my 3 and I'm going to multiply it by the 4. And in this spot, I'm going to say multiply because I'm going to treat those large numbers like regular numbers. I have 3 times 4, which equals 12. The next thing I'm going to do is I'm going to take my variable x to the third and x to the sixth, and I'm going to add those two things together. Here you see x to the third plus 6. They are adding them together to get their final answer. In total, it is 12 because 3 times 4 is 12, and then x to the third plus x to the sixth is 9. So they have x to the ninth power. Now, in doing all of that, I want you to notice something. You have to keep your bases the same, whether they're going to be coefficients or variables. You can only combine the two things that look alike and nothing else. So my 3 and my 4 can be multiplied, and my x's can be combined. That's because my bases are the same. Let's look at example number 1. We have 5x to the second power times negative 3x to the fourth power. So the first thing I'm going to do is I'm going to take my regular numbers or my coefficients, and I'm going to say 5 times negative 3, and I'm going to get the answer of negative 15. Then I'm going to look at my variables, and I have x to the second power and x to the fourth power. And I'm going to write those in a list, x to the second power, knowing that I'm going to add those two things together to get my total of x to the sixth power. So my final answer is negative 15x to the sixth power. Now I want you to notice that my coefficient is my big number, my variable is small next to it, and my exponent is raised and it's small as well. I started with two different terms with my number and my variable, and I ended with two different terms, my number and my variable. Let's try example number 2. I'm going to highlight my coefficients first. So I have 9 times 10 because there are parentheses next to these two things. So 9 times 10 is 90. And then I have x to the second power times x to the sixth power. And the way that I write that is x to the second power plus the sixth. I'm not rewriting my x, but in reality, I am saying that they're multiplied together, so I'm adding the exponents. And x to the second plus 6 is x to the 8th power. So my final answer is going to be 90 x to the 8th power. I'm going to pause my video right here, and I want you to do number 3 and 4, and then come back and check. All right, let's check your work. Did you do it correctly? Wonderful. Let's try example number 6 before we move on to the next set of exponents. I'm going to highlight my coefficients, and this time I'm not going to write it in a list. I'm just going to write out the answer as you normally would. So negative 3 times 6 is negative 18. Then I'm going to go to my x values, knowing that this x has an invisible 1 here. So x to the first power plus x to the second power is x to the third power. I just added those together. And then I'm going to go to my y values. And then I'm going to write down my y. And I have y to the second power and y to the third power. 2 plus 3 is 5. So my final answer is negative 18 x to the third, y to the fifth. Once you get all of this written down, go ahead and flip your paper over. On this page, we're talking about quotient of powers. When we're talking about quotient of powers, that means we are going to divide our large numbers and we are going to subtract our small numbers. Let me show you what I mean. In the example, we have 6x to the fourth divided by 2x to the second. So my regular numbers, or my coefficients, are 6 divided by 2. And we're going to treat those like regular numbers, and we're going to divide them. So 6 divided by 2 is 3. And then we're going to go over to our variables. And on this one, we have x to the fourth divided by x to the second. For that set of information, we're going to subtract it. And we know that 4 minus 2 equals 2. So their final answer is 3x to the second power. Seems super easy. Let's look at example number 7 and let's try it together. I'm going to break down the first two, and then from there we're going to go on and just write the answer. So on example number 7, we have 8x to the fifth power divided by 4x to the second power. So the first part that we're going to break down is 8 divided by 4, and that is 2. The second part is x to the fifth divided by x to the second, which means we're going to put x to the fifth minus 2 so that we can get our x value of x to the third. Your final answer is going to be written 2 times x to the third power. That's it. Let's try example number 8. You have 36x to the fourth, y to the seventh, divided by 18x to the second, y to the fourth. Now what I did is I highlighted all the things that look alike, all of the common bases, so that we know that those things have to stay together. The first thing that we're going to do is we're going to say 36 divided by 18, which is 2. Then we're going to take our x to the fourth, and we know that we're going to subtract that x to the second, and we will get x to the second. And then we're going to take our y value, and we have y to the seventh, and then we have y to the fourth. So we're going to say y to the 7 minus 4, and we are going to get y to the third. So our final answer is going to be 2 times x to the second times y to the third. All right, let's try one more of these. Let's go ahead and go over to example number 10. I'm going to highlight like I normally do. I have my coefficients, Then I have my A values, then my B values, oops, not that color, B values, then my C values. So we know how to keep them together. Okay, our first one is 28 divided by 16. This is going to give you a decimal answer of 1.78, but I don't want that decimal. I want to keep it into a fraction. So I know that both of these are divisible by 4, and this fraction is going to reduce to 7 over 4. Then I have my A values. I have A to the 5th minus A to the 2nd. That's going to give me A to the 3rd. Then I have my B value of B to the 2nd minus B to the 1st, because remember there's an invisible one right here. That's going to give me just B to the 1st. And mathematicians are lazy, so that's why you didn't see it there, so I'm not going to write it again. And then you have C to the 3rd minus C to the 2nd, which is C to the 1st. So my final answer would be 7 over 4 A to the 3rd B C. Now for the purposes of this video, I want to tell you that number 1, your variables need to be in alphabetical order, so that's why it's A, B, C order. But also we want to keep all of our positive exponents on the top of our fractions. Now, if you were to do this in another situation, you could just write 7 over 4 first, and then write your A to the 3rd, B, and C. This is correct, but this is the most correct answer. So if you have a testing situation, this is what your answer choice would look like. Now let's look at a power of a power. In this we have a to the m raised to the nth power. So what that means is I'm going to take this exponent that's on the outside and I'm going to multiply it by what is on the inside. This is what happens when you see a parenthesis, and you will multiply those two exponents together. So when we have a power or exponent raised to another power or exponent, we will multiply the two exponents. In this example, we have x to the 2nd raised to the 3rd power. So the shortcut is to take this 3 and multiply it by that 2 and get x to the 6th power. In reality, what you're saying is x to the 2nd times x to the 2nd times x to the 2nd. So x to the 2nd 3 times is x to the 6th. Now I want to give you another example just so that you can see what happens if you were to have a coefficient in the front. So in this example, I want to put 2 inside of parentheses, x to the 2nd raised to the 3rd power. If I have that, I need to remember that this 2 also has an invisible exponent of 1, and I'm going to take that 3 and I'm going to multiply it by the 1, and I'm going to multiply it by the 2. So my final answer would be 3 times 1 is 2 to the 3rd power, and then this 3 times 2 for my x value is going to be 3 to the 6th power. But see, I can't leave it like this because this is an actual number. This number is 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. So my final answer would be 8 to the times x to the 6th power. All right, let's try out example number 17. we have x to the fourth power is raised to the second power. So we're going to take this 2 and we're going to multiply it by 4. So over here I'm going to write x to the fourth times 2. And that's going to give me x to the eighth power. In example number 18, we have y to the eighth raised to the 1/2 power. So I'm going to write y to the eighth times 1/2. You can multiply whole numbers by fractions. In this case, you would get y to the fourth power. Now, when we talk about the zero exponent property, that is one that you are going to have to memorize, but have no fear, it's super easy. Anything raised to the 0 power, like this a to the 0 power, is going to equal 1. So let's jump right into our examples. We have 7 raised to the 0 power, that's 1. We have, in parentheses, negative 15 raised to the 0 power, that is also 1. In our last example, we have 8,675,309 raised to the 0 power. Guess what? That is also 1. So let's see what happens whenever we mix those variables with 0 powers with other things. Let's look at example number 11. We have x to the 0 power times y to the third power. In this situation, we know that our x to the 0 power is going to be 1. And then we haven't done anything to our y to the third, so we just rewrite it. Now remember that mathematicians are lazy. So instead of doing this 1 times y to the third, I'm just going to mark out the variable that's associated with my 0 power, and I'm going to rewrite everything else. So let's do that when we look at example 12. We have a to the second power times b to the 0 power times c to the 7th power. I'm going to mark out my b to the 0 power because I know it equals 1, and then I'm going to rewrite everything else as my final answer. So I have a to the second power times c to the 7th power. And that is all you have to do for your zero exponent property. Now we have one more property I want to talk to you about, and that is the negative exponent property. In this property, you're going to take all your sad exponents with the negative signs, and we're going to make them happy by moving them to the other side of the line. So what you're going to hear me say all the time is when you cross the line, you change the sign. When you cross the line, you change the sign. The line that I'm talking about this time is going to be my fraction bar, because all numbers can be made into a fraction, whether it's a whole number or it's already a fraction. In this example, you have 5 is divided by 3x to the negative third. They take that whole thing that's touching my negative 3 and they move it to the other side. So now they have 5x to the third divided by 3. Now I want you to notice you're only going to move the terms that are touching your negative sign. This x is touching my negative exponent, but this 3 is not. So the 3 will stay here, but the x and the positive 3 are going to move to the top. In example 13, we first need to make this into a fraction and put our invisible numbers. Then I want you to circle your variable and your negative exponent and put an arrow to where you want it to go. So our final answer is going to be 1 over or divided by a to the positive 8. Because we don't write our invisible one here, but we need to change this negative sign into a positive when you move it to the bottom. That was super quick and easy. Let's try example 13b. I'm going to turn this into a fraction. I'm going to circle my variable with my negative term, and I'm going to draw an arrow where I want it to go. Now I'm going to rewrite it as 5 all alone on the top, but on the bottom, I'm now going to have a to the 8th power. Got it? I want you to try number 14 on your own. Pause the video, come back and see if you got the right answer. Here's the answer. How'd you do? Let's try one more together. We have 5x to the negative second power times z to the third power divided by y to the negative 8 power. I'm going to circle the terms that I want to move, and then let's rewrite it. I haven't done anything to my 5, but I did do something to my x. I need to move it to the bottom so that it can be happy and positive. So x to the second power. And then I have z to the third power that I didn't do anything to on the top. But I do have y to the negative 8th power on the bottom that I need to move to the top. So I'm going to move it to the top and make it positive. And this is my final answer. Now I want you to notice something. I put these letters in alphabetical order. Whenever you have a testing situation, while it may be right that you put 5z to the third, y to the 8th over x to the second, it is not going to be the most right. And the most right is always going to be in alphabetical order. If you have any questions, please let me know. I'm happy to help.